All binomial expressions have got two terms, such as a plus b to the power n. So a plus b to the power 0, any number to the power 0 is 1, so that is going to be equal to 1. A plus b to the power 1 is going to be a plus b, just like that. A plus b squared is going to be a squared plus 2ab plus b squared. A plus b to the power 3 is going to become a cubed plus 3a squared b plus 3a b squared plus b cubed, like that. Now from the expansions of those, we are going to formulate what we call the Pascal's triangle. And the Pascal's triangle is simply a triangle that we use to expand to get these coefficients, the 3's, the 3's, the 1's, and so on. So we shall begin. The Pascal's triangle goes like this. We have here 1, 1, 2, 1. 2 plus 1 is 3. 2 plus 1 is 3. Here is 1. Here is 1. We proceed. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then we put here 1. We put 1. 4 plus 1 is 5. 6 plus 4 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Put a 1 there. Put a 1 there. 5 plus 1 is 6. 10 plus 5 is 15. This is 20. 10 plus 5 is 15. 5 plus 1 is 6. Then we put a 1, 1. Now the triangle continues. It goes on and on and on. It goes on and on and on. And this is what we are calling. Now what is the use of Pascal's triangle? Now Pascal's triangle is used to get coefficients of expressions of the form a plus b to the power n. In our previous example, we said a plus b to the power n is simply a plus b. That's to the power 1. Okay, a plus b squared is going to be 1 squared. The coefficient of a here is 1. Then the coefficient of the next term is 2. Then the coefficient of the next term is 1. So this line here applies to a plus b squared. Then let's go to a plus b cubed. A plus b to the power 3 is going to be a cubed. The coefficient of a squared is 1 there. The coefficient of the next term is 3, which is that. The coefficient of the next term is 3, which is also that. And the last coefficient is 1, which is that. So it means that this applies to a plus b to the power 3. And so on and so on. A plus b to the power 4, a plus b to the power 5, and 6. So in essence, we use this Pascal's triangle to simply find the coefficients of the terms in a binomial expression. So we shall look at an example here where we use this Pascal's triangle to expand. Use Pascal's triangle to expand that term, 3 plus x to the power 6. So we start by calculating. What is 3 plus x? 3 plus x to the power 6 is going to be equal to, this is the first term, this is the second term. So it's going to become expanding to the power 6. Now because it is to the power 6, we are going to expect to have 7 terms. If it is to the power 5, we expect 6 terms. If it is to the power 4, we expect 5 terms. If it is to the power 3, we expect 4 terms. So here it is 3 plus x to the power 6, so meaning that the terms in the expansion are going to be 7. So we shall simply start by stating them, the two terms, the first one and the second one. So we say this is 3x, that's the first term, plus so they make their 7 terms, 1, 2, 3, 4, 5, 6, 7. So now after drafting the 7 terms of that expression, so now we start awarding powers to each term. So let's look at the first term. The first term is 3, and 3 it's going to be having powers that are decreasing. The first term always has powers that are decreasing. The second term always has powers that are increasing from 0 to the value of n, in which case here the value of n is 6. So the first term here being 3, this is going to be 3 to the power 6, 3 to the power 5, 3 to the power 4, 3, 2, 1, 0. Then we get to the next term, the second term. For it will start from 0. 0, 1, 2, 3, 4, 5, 6. So after awarding powers to the terms, we now award the coefficients. This is to the power 6. Looking at our Pascal's triangle, this is a plus b to the power 2. This is to the power 3. This is to the power 4, to the power 5. So this is the line we are going to look at to the power 6. So we shall come and say here that the first coefficient here is 1. So this is 1. The next one is 6. The next one is 15. The next one is 20. The next one is 15. The next one is 6. And the next one is 1. So after adding the powers and after adding all the coefficients, so now we begin doing the rest, the arithmetic. There we have already expanded. It's like we've already gotten our answer. So we continue. And so this is the expansion of 3 plus x to the power x. And that's the answer. As simple as that. So in our expansion there, I want you to take note of this. That the powers of the first term keep decreasing. This is the first term. The powers keep decreasing from 6 to 5 to 4 to 3 to 2 to 1. The powers of the first term keep decreasing, and those of the second term keep increasing. The ones in green. The second term, which is x, the powers keep increasing. And that is true for all binomial expansions. Okay? And then the other term, the other fact you need to know. If the index is n, then we expect n plus 1 terms. The index in this case, I mean for instance here, the index of this is 6. So it means if the index is n, the value of the number of terms we expect is n plus 1. So in this case, because the index is 6, the terms are 7. That is what you simply mean. But now let's take a case in point. What if we are supposed to expand an expression like this? Here, the value of n is too large. It means that we're supposed, for us to get the coefficients, we're supposed to write this Pascal's triangle here. This is to the power 2, to the power 3, to the power 4, to the power 5, to the power 6. We are supposed to continue with this triangle, that pyramid, up to the point where we are supposed to get coefficients that are 50. Now that is hectic work for us to continue with the Pascal's triangle, so that we are able to get our coefficients of these terms where the value of n is 50. It's very hectic. Now when the value of n is large, it means we are going to use the binomial theorem, which is that a plus b to the power n is equal to that, and the value of r is running from 0 to n. This is the binomial expression that we are going to use when the values of n are very large. So let's take a case in point. Let's say we have to expand 1 plus x to the power n. Now the value of a is 1. How do we expand this? Now expanding this binomially, it means we are going to use this expression, the binomial theorem, to expand this. So it means it's going to become n combination r, that is going to be a, which is 1, to the power n minus r, which is, this is now n combination r is starting from 0, so this is 0. N minus 0 times x to the power 0 plus n combination, this is 2, times 1 to the power n minus 2 times x squared plus n combination 3, r is 3, times 1 to the power, that is going to be n minus 3 times x to the power 3, and so on and so forth. So in our expansion there, we know that is 1 to the power any number, it's still going to give us 1. So meaning that 1 to the power this is going to give us 1. 1 to the power this is still going to give us 1. Whatever figure is there, whether it's 1 to the power 1000, 1 to the power 1 million, the answer will always still be 1. Then we have this n combination 0. Now how do we sort this? How do we express this mathematically? N combination 2, n combination 3. If we knew the value of n, we would just put the figure and just punch it in the calculator and get the answer. But in the event that you do not have a calculator, this is how you find the value of n. N combination 0. Now from here you should know that n combination r is equal to n factorial over n minus r factorial times r factorial. What do I mean by factorial? By factorial, I mean n factorial is the same as saying n times n minus 1 times n minus 2 times n minus 3, and so on until the value of n diminishes to 1. Let's take a brief example here. For example, what is 5 factorial? 5 factorial is the same as saying 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 times 5 minus 4. So this is going to become 5 minus 1, it's times 4 times 3 times 2 times 1, and the answer here is 120. So 5 factorial is 120. This is what I mean by n factorial, and so on. To continue with what we were doing before, I said that we wanted to find what is 1 plus x to the power n. N combination 0. So expressing that from using that what we did before, it's going to become n factorial over n minus 0 factorial times 0 factorial, that is times x to the power 0, plus n factorial over n minus 1 factorial times 1 factorial, that is times x to the power 1, plus zero factorial is 1, n minus 0 is simply n factorial, so n factorial and this will cancel out. 0 factorial is 1, so here it's going to become x plus n factorial is going to be, this is plus n times n minus 1 factorial over n minus 1 factorial times 1 factorial x to the power 1, plus this is going to become n times n minus 1 times n minus 2 factorial over n minus 2 factorial. 2 factorial is simply 2 times 1, that is x squared, and so on and so on. So we shall end up with x plus, this will cancel with that, you remain with plus nx, plus this will cancel with that, so we remain with plus n into n minus 1, that is x squared over 2, plus until the series continues, you continue with the next term x to the power 3, and so on. So in essence, this is, and remember this is x to the power 0 is 1. This is x to the power 0, remember? So we are going to end up with 1 plus nx plus n into n minus 1 x squared over 2 plus blah 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 blah. So meaning that for our the general term, in case the value of a is 1 here, if the value of a is 1, it means that our general expression, the binomial expression for such, will always be that. And so that is the expression in case you have to do it like that. Or 1 plus x to the power n is going to be simply be 1 plus n combination 1 x to the power 1 plus n combination 2 x squared plus n combination 3 x cubed, and so on and so on. Now these combinations I've just converted, because you can get these using calculators. You can just punch it in the calculator. If the value of n is 2, it's 2 combination 1, you get your answer. These combinations is what is being replaced by n factorial over n minus 1 in brackets factorial times 1 factorial, and so on. So now let's do an example on this. Expanding 1 plus x to the power 9, that is going to be equal to, using this, let's put it, it's going to be 1 plus nx plus n into n minus 1 x squared over 2 factorial plus n into n minus 1 n minus 2 x cubed over 3 factorial. So that's going to become 1 plus nx. What is the value of n here? It is 9. So it is 9 times x plus, what is n? 9 into 9 minus 1 over 2 factorial, which is 2 times 1. That is going to be x squared plus, that is 9 into 9 minus 1 into 9 minus 2 x to the power 3 over 3 factorial. 3 factorial is 3 times 2. So now our answer there will simply be 1 plus 9x plus 9 times 8 divided by 2, we end up with 36 x squared plus 9 times 8 times 7, that is divide all that by 6, we are going to become, it's going to become 84 x 3. And so this is our expression for 1 plus x to the power 9. As simple as that. That is how we expand that. Now if we're told to evaluate something else, let's take a question here. Okay, hence evaluate 1.01. Evaluate 1.01 to the power 9. Now evaluating, after expanding this 1 plus x to the power 9, we know the expansion for this binomial expression, and now they're asking us to use this to evaluate this. This 1.01 is the same as saying 1 plus 0.01. This is to the power 9. Yeah. So if we compare this to that, you will find that our value of the 1 and 1, these are the same. Our values of x, our value of x has gained a value. Our value of x now in this case is 0.01. So in this case here, it is just a matter of substituting this value of x in this expression. Since the expansion of 1 plus x to the power 9 is this, so we just simply substitute 0.01 in that expression and we get our answer. So it means in this case 1 plus 0.01 plus 0.01 to the power 9 is simply going to be 1 plus 9x. X is 0.01. So 9 times 0.01 plus 36 into 0.01 squared plus 84 into 0.01 to the power 3. Our answer here is going to be 1.0937, and that is correct to 4 decimal places, and that is our answer. We are being asked to expand 2 plus x to the power 5 and use this expression to find this. So first of all, we are going to have to first begin by expanding this expression. After expanding this expression, then we use the expansion to solve for this and that. We need to remember that in any binomial x, the binomial theorem states as it goes as that a plus b to the power n is the summation of n combination r a to the power n minus 1 b to the power r for values of r running from 0 to the value of n. So this binomial theorem is exactly what we are going to use to expand that. So we begin. This is going to be 2 plus x to the power 5, that is going to be equal to, using this, it's going to mean that it's going to be, our value of n is 5, so it's going to be 5 combination r. What is r? Of course here we are going to start with 0 times a. What is our value of a? It is 2 to the power n minus 1, that is this is n minus r actually, so it's going to be to the power 5 minus 0 times b, which is going to, in this case, is x to the power r. And what is our r? 0. Then we continue, so it's going to be plus 5 combination 1 2 to the power 5 minus 1 times x to the power 1 plus 5 combination 4 2 to the power 5 minus 2, I mean 5 combination 2 to the power 5 minus 2 times x squared. It's quite a long one. We continue here, it's going to become 5 combination 3 times 2 to the power 5 minus 3 x cubed plus 5 combination 4 times 2 to the power 5 minus 4 times x to the power 4 plus 5 combination 5 times 2 to the power 5 minus 5 times x to the power 5. So that is going to become, this will become 5 combination 0, that is 2 to the power 5 times x to the power 0 plus 5 combination 1 2 to the power 4 x to the power 1 plus 5 combination 2 2 to the power 3 x squared plus 5 combination 3 2 to the power 2 x to the power 3 plus 5 combination 4, that is 2 to the power 1 x to the power 4 plus 5 combination 5 2 to the power 0 x to the power 5. Now if you notice here, if you take note that the values of 2, which we are calling the first term 2, the value of 2, the power to 2 goes on increasing to 5, 4, 3, 2, 1, 0. And in the second term, the value of x goes on increasing, x to the power 0, 1, 2, 3, 4, 5. So, and then this 5 combination 0, this is the coefficient of each of those terms. And so as we continue with this expression, now we want the coefficients, we go on and expand them to get more. So this Continuing from our previous number, that is going to become 5 factorial over 5 minus 0 factorial times 0 factorial, that is x to the power 0, plus 5 factorial over 5 minus 1 factorial times 1 factorial, that is x to the power, I'm looking at this here, 2 to the power 4 times x to the power 1, so that is 2 to the power 4 times x to the power 1, plus 5 factorial over 5 minus 2 factorial times 2 factorial, that is times 2 to the power 3 here, 2 to the power 3 x to the power 2, plus the next term is 5 factorial over 5 minus 3 times factorial times 3 factorial, that is 2 2 to the power 2 x to the power 3, plus the other terms we'll write them here, 5 factorial over 5 minus 4 factorial, that is times 4 factorial, that is 3 to the power, that is 2. This was 2 to the power 2, 3, 2, that's 2 to the power 1, times x to the power 4, plus 5 factorial over 5 minus 5 factorial, that is times 5 factorial, that is times 2 to the power 0, x to the power 5, like that. This is 5 factorial, 5 minus 0 is the same as 5, 5 factorial over 5 factorial, this will cancel with that, and you end up with 0 factorial. 0 factorial is equal to 1, any number to the power 0 is 1, so this whole expression is going to simply become x to the power 0, but it is going to be it is x to the power 0 times 2 to the power 5. We remain with, I've forgotten that 2 to the power 5. So it's 2 to the power 5 times 5, it's going to become 2 to the power 5. 2 to the power 5 plus, this is going to be 5 factorial is 5 times 5 minus 1. We shall stop there. 5 times 5 minus 1 factorial times 2 to the power 4 times x, because x to the power 1 is x. Divide all that by 5 minus 1 factorial times 1 factorial. This will disappear with that. We continue, plus 5 factorial, which is, this 5 factorial is the same as saying 5 into 5 minus 1 times 5 minus 2 factorial. Divide that by, what is 5 minus, that is 5 minus 2 factorial. Multiply that by 2 factorial. All this multiply that by 2 to the power 3. 2 times 2, 4, 4 times 2 is 8, so that is 8x squared. This cancels with that. You add, you continue to the next term. The next term, I don't think it will fit there. The next term will be, let's start from this way, plus 5 into 5 minus 1 into 5 minus 2 into 5 minus 3. Divide all that by, this is continuous factorial, times 2 to the power 2, 2 times 2, that is 4, that is times 4, x to the power 3, that is x cubed. Divide all that by 5 minus 3, so it's going to become 5 minus 3 factorial. Multiply that by 3 factorial. 3 factorial is 3 times 2 times 1. So this 5 minus 3 cancels with that, and you remain with the rest. We continue, plus that next one it's going to become 5 into 5 minus 1 times 5 minus 2 times 5 minus 3 times 5 minus 4 factorial. Divide that by what is in the denominator. We have, this is x to the power 3, so this is x to the power 4, so this is 2 to the power 1. 2 to the power 1 is 2 times x to the power 4 over 5 minus 4 factorial times 4 factorial. 4 factorial is 4 times 3 times 2 times 1. So this 5 minus 4 factorial goes with that 5 minus 4 factorial. Then we have that last term, let's put it here, it is quite long, plus 5 factorial, it's going to become 5 into 5 minus 1 into 5 minus 2 into 5 minus 3 into 5 minus 4 into 5 minus 5. Any number to the power 0 is 1, so this is 2 to the power 0 is 1, then times x to the power 5. So here we have x to the power 5, divide all that by 5 minus 5 factorial. 5 factorial here is going to be times 5 times 4 times 3. No, this is times 3 times 2 times 1. So this is going to become 2 to the power 5 is 32 plus the next, this is 2 to the power 4 times 5 divided by 1, that is going to become 80x. That's going to become plus this, which is going to become 80 x squared, plus this, that is going to become plus 40 x cubed, plus this, that is going to give us 10 x to the power 4 plus this x to the power 5. So this becomes our expression for our expansion for x plus 5, and 1 over 1 minus 2x in bracket squared in ascending powers of x. So we are going to do this in ascending powers of x. We are going to expand this expression, and we are supposed to include terms up to x to the power 3, and then we state the values of x for which the expansion is valid. So we begin. So we are expanding this value 1 over 1 minus 2x. This is to the power 2. This is the same as saying 1 minus 2x to the power negative 2. This is the binomial expression we're now going to expand. Expanding this binomial expression means that our value of n is negative 2. This is our value of a, and that's our value of b. So since it is 1 plus negative 2x, we are going to use this expression to expand it, just like I had introduced it in our earlier videos. So meaning, in that case, 1 minus 2x to the power negative 2 is going to be equal to, that's going to be 1 plus nx. What's the value of n? It's negative 2. So it's negative 2 times x. Now our value of x is negative 2x. All this is the value of x. So it's times negative 2x plus n, which is negative 2, into n minus 1, which is negative 2 minus 1, over 2 factorial. 2 factorial is 2 times 1, that is x squared. Now what is x squared? X is negative 2x, so it's going to be negative 2x. All this thing is squared, plus n, that is negative 2, times negative 2 times negative 2 minus 1, negative 2 minus 1, into negative 2 minus 2 minus 2 minus 2 x cubed Now our value of x, remember, is negative 2x, so it's going to be negative 2x to the power 3. Divide all this by 3 factorial. What is 3 factorial? It is 3 times 2 times 1. That is 3 factorial. So after substituting like that, the binomial expression for that is this, and we have found the answer. Now we are being asked to find. The question says that find and state the values of x for which the expansion is valid. Now the values of x for which the expansion is valid, what do we have in that place? We have a negative 2x here in the value of x. So, and we say that the range of that should be from negative 1 to 1. So in that case, it is going to be the range of values of x are negative 1 is less than or equal to negative 2x is less than or equal to 1. So it means the real range of values of x are going to become, if we divide through by negative 2, it is going to become, this is a half less than or equal to x less than or equal to negative a half. So in other words, to state it correctly, it will be negative a half less than or equal to x less than or equal to a half. So these are the range of values for x. The next question, we are being asked to obtain the first 4 terms in the expansion, in that expansion 1 plus x to the power half, in ascending powers of x, and we state the values of x for which the expression is valid. To become 1 plus 8x to the power half is going to be equal to 1 plus nx. What's the value of n? The value of n is a half. So it's going to be a half times the value of x. What's the value of x? It's 8x. 8x plus n. What is n? Is a half into a half minus 1 times 8x squared over, what is 2 factorial? That is 2 times 1 plus, that's the value of n. That is a half times a half minus 1 into a half minus 2 times a half minus 2 times x. What's the value of x? The value of x is 8x to the power 3. All this is divided by 3 factorial. What is 3 factorial? 3 factorial is 3 times 2 times 1. So when we compute all that, we shall end up with 1. Plus 8x to the power half. That's the binomial expansion. So now we answer the other part of the question. They're asking us that state the values of x for which the expansion we are talking about is this. So the values of x should range between negative 1 and 1 for whatever is in the part of b. So here it's going to be negative 1 is less than or equal to 8x, which is less than or equal to 1. If we divide through by 8, we shall end up with negative 1 over 8 is less than or equal to x is less than or equal to 1 over 8. And now this is a continuation of that question. They're telling us that by putting x as 100, we've already gotten the expression for this binomial, and it's that, and they're telling us to put x as 100. So what we do, we simply say 1 plus 8x to the power half. First of all, the expression is 1 plus 4x minus 8x squared plus 32 x to the power 3. And now they are telling us to put our value of x as 100. Now putting our value of x as 100 means that it's going to be equal to 1 plus 4 times 1 over 100 minus 8 into 1 over 100 squared plus 32 into 1 over 100 to the power. Remember, this is the same as saying this way. It's going to be 1 plus 8 times x. X is times 1 over 100. This is to the power a half. So meaning that when we add 1 plus 8 over 100, 1 plus 8 over 100 is going to give us the LCM here is going to be 100. So it's going to become 100 plus 8. So 100 plus 8 to the power half is going to give us, when we expand, compute all this, it's going to give us 1.0392232. Remember, anything to the power half is the same as saying the square root. This whole thing and the square root of the numerator is what we shall be left with to compute. So it's going to become the square root. 100 plus 8 is the square root of 108. Divide that by the square root of 100, which is 10, is giving us 1.0392232. So it means that this is going to be the same as square root of 108 is giving us, if we multiply 10 on both sides, it's going to become 10.39232. Now from this Sadic quantity, our target here is to make sure that from this we generate a root 3 somewhere, because they're telling us that when we substitute the value of x in this expression, we're supposed to find the value of root 3. So when reaching at this point, we're supposed to make sure that we generate a root 3 from here. So if you look at this 108, 108 is the same as saying the square root of 3 times 36. That's going to be 10.39232. Square root of 3 times 36 is the same as square root of 36 is 6. Square root of 3 is what we're looking for. So this is going to become 6 times the square root of 3, giving us 10.39232. And so we shall end up with the square root of 3 giving us 10.39232. Divide that by this 6. And so meaning that our final answer for the square root of 3 will still be giving us 1.732053. And from there we will have achieved our answer for the square root of 3. We have answered the question. We have a question here. It's saying that show that if x is small enough for its cube and high powers to be neglected, then this expression is equal to that expression. In essence, we're supposed to expand this expression to show that it is equal to that, because the value of x, according to the question, is saying that x cubed, the value of x is too small that we shall ignore x to the power 3, x to the power 4. So we shall expand this up to x to the power 2. And then after showing that this is equal to that, we're supposed to go ahead and say and show that root of 7 is equal to this expression when we put x as an a. By putting x is equal to 1 over 8, show that the square root of 7 is equal to that. Starting with this side, that is 1 minus x over 1 plus x. That's going to be equal to, we are going to now rationalize the denominator and multiply both down and up. So in this case it's going to become 1 minus x over 1 plus x. So in rationalizing the denominator, it means that here we are going to multiply the denominator by 1 minus by its conjugate, and we do the same to the numerator. We multiply by the conjugate of this. It's going to simply become 1 minus x squared, divide all that by 1 minus x times 1 plus x plus 1 minus x. This is the difference of two squares, so it's going to become 1 squared minus x squared. So we continue. This is the same as saying 1 minus x squared over 1 minus x squared. All this is to the power a half. So that being to the power a half means it's going to become 1 minus x squared to the power half. So this half times 2 is going to give us 1. So it's 1 minus x to the power 1 times 1 minus x squared to the power negative a half. So now we're supposed to expand this. We expand it to make sure that it is equal to that it is equal to this expression. So we continue by saying this expression, the first one is already expanded. As in, for us to expand 1 minus x to the power 1, the expansion is 1 minus x. So now what about this? 1 minus x squared to the power negative a half. 1 minus x squared to the power negative a half. It means that our value of n is negative a half. And since the value of a is 1 and the value of b is x squared, so we are simply going to use that expression like we have been using in our previous videos. So it means that in this case, substituting in here, our value of x here is actually x squared. So this 1 minus x squared, x squared to the power negative a half, to the power negative a half is going to become 1 plus our value of n, which is negative a half, times our value of x, which is negative x squared, plus n. What is n? N is equal to negative a half times n minus 1, which is negative a half minus 1. Divide all that by 2 factorial. 2 factorial is 2 times 1 times x squared. Our value of x is negative x squared, so it's going to be negative x squared, and that's to the power 2. And we continue with the third term, which plus, substituting in this, is going to become negative a half into negative a half minus 1, so it's negative a half minus 1 into negative a half minus 2, negative a half minus 2 times x to the power 3. What is x to the power 3? Our value of x is negative x squared, so it's negative x squared to the power 3. Divide all that by 3 factorial. 3 factorial is 3 times 2 times 1. So our expansion there is simply going to become, so that's going to become 1 plus x squared over 2 plus 3x to the power 4 over 8. So the expansion for 1 minus x squared to the power, this being the value of n, is giving us this. But from our question, they are telling us that its cube and high powers are going to be neglected because x is small enough. We're supposed to show that if x is small enough for its cube and high powers to be neglected, then this is equal to it. Since now the x is small enough and its cube and high powers are going to be neglected, it means we shall neglect this x to the power for this term. So if we are to neglect that term, it means that this is going to become 1 plus x squared over 2 plus 1 plus x squared over 2, that is 1 minus x squared to the power negative a half. So that is the expansion for this. Then going back to our question, taking it back from where our original question, remember, is we are trying to expand this. And from our previous working, it has been this, that 1 minus x over 1 plus x. Now after rationalizing the denominator here, we ended up with 1 minus x into 1 minus x squared to the power negative a half. Now we said that the expansion for this is known. 1 minus x is already expanded because 1 minus x to the power 1 is the same as saying 1 minus x. Then what we were doing before, we were trying to get the expansion for this, the binomial expansion, and we got it. 1 minus x squared to the power negative a half is equivalent to this term. So it means that we are simply going to come and say it's going to be 1 minus x, multiply that by 1 plus x squared over 2. we open brackets. 1 times 1 is 1, plus 1 times that is x squared over 2. This times that is minus x. This times that is minus x cubed over 2. So there we shall get our answer as 1 minus x plus x squared over 2. We shall ignore this. Why? We ignore this because the question is still telling us that the cube and the higher powers can be neglected. And so in essence, here we have shown that we have answered the question. 1 minus x over 1 plus x is equal to that. We have shown our question, what is required. Show that this is equal to that. And we have shown it there. So, the other part of the question is saying that by putting x as 1 over 8, show that the root of 7 is equal to that. So now if we are to put 1 over 8 in the place of x, we are supposed to manipulate this square root side to make sure that we get a root of 7 and we make sure that it's equal to that number. So continuing from there, to answer the second part of our question, we shall simply substitute. This is going to become 1 minus, what is x? We are putting x as 1 over 8 according to our question. So it's 1 over 1 over 8. Divide that by 1 plus 1 over 8. That's going to be equal to 1 minus 1 over 8 plus, this is x squared. X squared is 1 over 8 squared. Divide all that by 2. So now that will give us 1 minus 1 over 8 is going to give us 7 over 8. Divide that by 1 plus 1 over 8 is going to give us 9 over 8 is equal to, now all this is going to give us 1, 1, 3. Divide that by 1, 2, 8. When I punch it in my calculator here. So after getting that, this is the same as saying 7 over 8, this is like 7 over 8, divide that by 9 over 8, the square root of 7 over 9, giving us 113 over 128. So here we have the square root of 7, divide that by the square root of 9, which is 3, giving us 113 over 128. And so here the final answer will be the square root of 7, giving us, multiply 3 on this side. It becomes 113 over 128, multiply that by 3. Here it's times 3, times 3. This 3 dies with that. So it becomes like that. So the root of 7 is that. And when we manipulate that, the square root of 7 is going to give us, this is going to give us two whole numbers, 83 over 128. And two whole numbers, 23 over 128, we have just proven this. Root of 7 is equal to two whole numbers, 83 over 128. And that is the answer for that question. That is a binomial expression, and if we are to expand that binomial expression, it's going to be, we are going to use the binomial theorem to expand this. Now if we are to use this binomial theorem to expand this, it will simply be 3 plus x to the power 2 is going to be equal to, what's the value of n here? It is 2, so it's going to be 2 combination r. What is r? Combination 0, because r is running from 0 to the power to the value of n, times a is 3, so it's 3 to the power n minus r. What is, that's 2 minus 0, which is 2, times b. b is x, so it's x to the power r. In this case r is 0. That is plus 2 combination 1 times 3 to the power 2 minus 1, which is 1, times x to the power 1, plus 2 combination, now r here is 2, times 3 to the power 2 minus 2 is 0, times x to the power 2. So now here our expansion is going to become Now 2 combination 0 is the same as 2 factorial over 2 minus 0 factorial times 0 factorial, that is x to the power 0. Any number to the power 0 is 1, so that is times 1, plus 2 factorial, divide that by 2 minus 1 factorial times 1 factorial, that is times 3 to the power 1, which is 3, times x to the power 1, which is x, plus the third one, which is 2 factorial over 2 minus 2 factorial times 2 factorial, multiplied by that 3 to the power 0. Number to the power 0 is 1, so this is 1 times x squared, that's times x squared. So we continue. This is going to become we forgot here, this is x to the power 0 is 1, then this 3 squared, 3 times 3 is 9, this is times 3 squared, so this is times 1 times 9, that we are adding that, plus 2 factorial is 2 times 1, which is 2 over 2 minus 1, that is 1 factorial times 1 factorial times 3x, plus 2 factorial is 2 times 1, which is 2 over 2 minus 2 factorial, that is 0 factorial. 0 factorial is 1 times 2. 2 factorial is 2 times 1, which is 2. That is times x squared. We continue. So, as we proceed, so now this is the expression, the expansion for 3 plus x squared. It is 9 plus 6x plus x squared. We expanded that using the binomial expression. So now if you realize that we got this 9 from this, from that, yeah, this whole thing, we got this 6x from this, and also we got this x squared from this. What am I trying to show you? I'm trying to show you that we got this 9 from that, this from that, this from that. That is how we're able to get those terms. So now these are what we are calling the terms of the binomial expression. And so now here this video is telling, we need to show how do we find the coefficient of the term of the binomial expression. If this is a term in a binomial expression, this is the coefficient of that term. Okay, this is a term in a binomial expression, so this is called a constant term. A constant term is a term in a binomial expression that does not have an unknown attached to it. This one is a term, it has got an unknown x attached to it. This one is a term of a binomial expression, its unknown is x squared, so the coefficient of this is 1. So this video we want to find the coefficient of the term in a binomial expression. So you should know that the rth term of a binomial expansion is given by that ur plus 1 is equal to that. This is what the binomial expression, and it's what we used. So we shall go ahead and just illustrate how we find the term, the coefficient, by using just one example. Find the constant term in the expansion of x minus 1 over x to the power 8. Now the constant term here, in this case, this is the constant term. The term where the value of x is to the power 0, where there is no value, no unknown. That's the constant term, it's what we are supposed to find here. So we proceed to start with our working. It is going to be x minus 1 over x to the power 8. Compare that with a plus b to the power n. What is our value of a? Our value of a is x. And what is our value of b? Our value of b is this. That is our value of b. So when you compare those two, then now you now substitute them in this. We are supposed to first find the value of r there. So using that thing that UR is going to be equal to n combination R A to the power n minus R B to the power R. What is n? Our value of n is 8, so it's going to be 8 combination R. We're supposed to first get the rth term. 8 combination R times A. What is A? A is x, so it's going to be x to the power n minus R. That is 8 minus R times B. What is our value of B? Negative 1 over 8. So our value of B is negative 1 over x to the power R. Okay, so now in this expression we work towards making sure that the x's are put together. So we continue. This is going to be 8 combination R times x to the power 8 minus R. That is, multiply that by, this is negative 1 to the power R times x to the power negative R. So we put the x's together. So that is going to become 8 combination R times x to the power 8 minus R times x to the power negative R times negative 1 to the power R. So that will give us 8 combination R. That is, using our laws of indices, this is the same base. So because the bases are the same, we shall add the powers. So it's going to become x, this times that, we add the powers, 8 minus R plus minus R is going to give us 8 minus 2R times negative 1 to the power R. Now from here we can see that we have put the value of 8. X is alone and the other terms are alone. Now the question is telling us that we need to find the constant term of this expression. Now for us to be able to get the constant term of this expression, it means that this value of R, this power of x, should be equal to 0. Because any number to the power 0 is 1, and that is how this x disappears. So for us to know the coefficient of the constant term in that binomial expression, this should be equal to 0. So for constant term, eight minus 2R should be equal to 0. So this means that negative 2R is going to be equal to negative 8. Divide both sides by 2. This goes with that. So you end up with our value of R giving us 4. So meaning that if our value of R is 4, it means we can now find the coefficient. So looking at the rth term, UR plus 1 is going to be equal to n combination R, that is a to the power n minus R times b to the power R. Here UR is 4, so it's going to be, our fifth term is therefore going to be n combination R. In this case it is 8 combination, our value of R is 4, 8 combination 4 times our value of A. What is our value of A? Our value of A, this x to the power 0, because if our value of this is equal to 0, 4 times 2 is 8, 8 minus 8 is 0, times negative 1 to the power R, which is 4. So of course now here we shall end up getting x to the power 0 is simply going to give us 1. So we shall end up with our U5 as 70. So it is 70, and so that is the constant term. First of all, we're supposed to first find the value of R. How do you find the value of R? This. Compare 2x plus 1 over x to the power 7. Compare that with A plus B to the power n. When we compare those two, you find that our value of A is that, and our value of B is this. That's our value of B, and that's our value of A. So meaning that if we are to substitute it in our general expression, U into R plus 1 is equal to N combination R A to the power N minus R B to the power R, you will find that our value of N here is 7. So it's going to be 7 combination R, we are looking for that R, times A. Our value of A is 2x. So times 2x to the power N minus R, that is going to be 7 minus R, times B. What is our value of B? 1 over x to the power R. So we continue just like we did in the previous question. It's going to become 7 combination R, 7 combination R times 2x. What is 2x? It's going to become 2x to the power 7 minus R times, that is going to become 1 to the power R times x to the power negative R. X to the power negative R. So we put the x's together. Let's continue simplifying. This is going to become 7 combination R times 2 to the power 7 minus R, as in this is 2 times x, all this is to the power that. So this, it's the same as saying this to the power that, 7 minus R times x to the power that, x to the power 7 minus R times 1 to the power R, 1 to the power R times x to the power negative R, x to the power negative R. So we group up all the values of x together and the rest together. So it's going to become 7 combination R, this value of x, x to the power 7 minus R, times this value of x, x minus R, then times 2, 2 to the power 7 minus R times 1 to the power R. And so there we shall end up with 7 combination R is going to give us, this is using our laws of indices, the bases are the same, so we add the powers when the bases are the same. So the base here, x, is the same, so when you add the powers here, you're going to end up with 7 minus 2R times these other constants, which is going to be 2 to the power 7 minus R times 1 to the power R. So now after putting x to be alone, now they are asking us to find the coefficient of x to the power negative 5. That is the coefficient of x to the power negative 5. That is what is in the question. Now it means that for us to get the coefficient of x to the power negative 5, this should be equal to that, negative 5. So to get x to the power negative 5, it means that 7 minus 2r should be equal to negative 5. So we find the value of r for which this whole thing is negative 5. So it's going to become negative 2r is equal to negative 5 minus 7. Negative 2r is going to be equal to negative 5 minus negative 7 is negative 12. Divide both sides by negative 2, divide both sides by negative 2. You will get your value of r as 6. So after getting our value of r as 6, we are going to come and substitute it back in this expression. So when we substitute it back in this expression, then we are able to get the coefficient for which x is negative 5, just like our question wants. So we go ahead and say our u into r plus 1 is going to be equal to, it's n combination r times a to the power n minus 1 and minus r times b to the power r. What is our value of r is 6, so it is u 7, our 7th term, therefore it's going to become n, in this case we just put this, so it's going to be x to the power 7 minus 2r, so it is 7 combination r, which is 6, times x to the power 7 minus 2r, r is 6, times it's going to be times 2 to the power 7 minus 6. 2 to the power 7 minus 6 times then 1 to the power r, and r is 6, so it's going to be 1 to the power 6. So that is going to become 7 combination 6. Multiply that by x. 7 minus this is supposed to be negative 5 to the power negative 5 times 2 to the power 7 minus 6, that is 2, because 2 to the power 1, then times 1 to the power 6 is times 1. So the answer we shall get there, of course, this is going to be 7 factorial over 7 minus 6 factorial times 6 factorial, that is times 2 times 1, which is 2, times x to the power negative 5. So this is going to become 7 times 7 minus 1 factorial over 7 minus 6 factorial times 6 factorial, that is times 2 times x to the power negative 5. So you'll notice here that 7 minus 1 factorial is 6 factorial, so this will cancel with that. You remain with 7. 7 minus 6 factorial is 1, so 7 times 2 is 14. So this is going to become 14 x to the power negative 5. So it means that the coefficient of that value is 14, and that's the answer. That's the coefficient